Hello and welcome back. This time I'd like to talk a bit about variables and types. So here we have the previous Hello World program that we had, and suppose if you have a Java class like this, usually to create a list, you would say something like this. And so this is saying you have an interface of type list, and you're assigning a variable myList into that variable, and it's actually constructing using an ArrayList. This is the diamond operator from Java 7. And so again, if we convert this to Kotlin, then it looks like this. So there's a few things to notice here. First of all, there's no new keyword. New is gone. You call it like a function, and it instantiates the object. But here, so we still have the variable name, obviously. And then here we have val, and val isn't exactly equivalent to what we had before. What we actually had before, if we were to translate it literally, would be var. And var means it behaves like a regular Java variable, where you can reassign it to, right? You can reassign it to a new object if you want to. So in general, good programming practices suggest you don't reassign variables most of the time. You don't really need to, and it can make things harder to understand if you have to keep track of what the current value of a variable is. So what you do in Java, if you have one of the things you're kind of supposed to do, but is not super common, is if you have a variable that you're not ever going to change, you're supposed to make it final. And this is especially true for fields, and it's kind of, you should do it for parameters, method parameters, and for local variables, but I find it just so verbose that like all this line is doing is creating an array, and it takes up so many extra characters, creating a list, that it's I don't feel like instead of having final, you should just have a shorter method that makes it obvious that you're not modifying this variable. Anyway, so Kotlin gets around all this by just creating val. So val is exactly the same as a final variable. You can mutate the thing that it points to. You can add things to it, for example. But if you try to reassign it, then it's not going to let you do that. It's going to say val cannot be reassigned. If you really do need such a thing, you can change it to a var. But again, try to avoid doing that if you can. Like 90% of the time, you don't need var. And if you're careful, you can actually structure your code so you never need var, unless you're doing esoteric, performance-sensitive, whatever. Okay, so something else you may have noticed that is different from the previous code is there's no mention of list string anywhere. And that's because Kotlin has type inference for local variables. Here, if you hit Control Q, you can see that this list is of type ArrayList. So if you don't want to use type inference, you can say, well, I mean, you can actually say this. And then the nice thing about that is then you can just chop this off completely. You don't need to say diamond operator, it'll guess for you. So there's only two reasons to use an explicit type on a local variable like this. One of the reasons is documentation. If you if you're calling a method here, you're calling a method here and it's not 100% clear, it's not 100% clear what that is, then sometimes you'll want to say, okay, here's what this is. Or if it's returning like a complex generic, like, if it's returning something like this, sometimes you want to put that just right here in your code so it's easier to read. The other reason to do it is sometimes if you have an array list here, again, then you might want to say, okay, so array lists have mutators and certain methods on them, but if you want to upcast it to something that doesn't, list of string, now you can't, there's no add method on that interface. So it still works, but you can only do get operations and stuff like that because list is the list interface in Kotlin is slightly different than that in Java, and that it doesn't have any of the mutator methods, it doesn't have setters. So that's basically all there is for parameters. For local variables. Parameters are should be familiar to this syntax. So you always need to say the type, and then the name of the value, and then the type. You don't say for parameters. You don't say val or var. They're implicitly vals. You can't reassign parameters like this. This is a best practice in Java, but it's actually just straight up required in Kotlin. You can't mutate parameters. If you want to mutate them, then you just reassign it to a variable, and then if you want to actually reassign, then whatever. You're allowed to reassign things, but you have to make a copy of the reference first, just like this. And that's kind of the basics for variables. I'm going to talk a little bit about fields, because fields they're kind of like variables. So you can say private val something like this, and it works how you'd expect. You can't reassign it because it's a val. Pretty clear. You can also say private var. I'm not going to show you because that's the same as everything else. You can still say list of string, and then you can drop this side off. While we're here, I don't think this is very idiomatic. You don't normally define array lists like this. If you want a list in Kotlin, there's a helper method that they provide called okay, it depends on what exactly you're looking for. There's two methods. There's mutable list of, and it's vararg. So you can either, if you want a mutable list of string, this is it. Or if you want to initially populate it with this, then you can. And then this becomes optional because it has to be strings. But you can also mix types. But if you look at the type of my list now, it's now any, because you have string, because it contains strings and ints. So there's no kind of common type between them. But in general, you won't be doing that. So if you actually look at mutable list of, it's an array list. It never uses linked lists, which is fine 90% of the time. Obviously, use a linked list if you're mutating things at the beginning or the middle of the list. Like that's normally when you do, but otherwise, array lists are going to perform better. Yeah, so this returns a type of mutable list. So mutable list is exactly what it sounds like. It's a list that has methods that let you change it. But if you don't want a mutable list, if you want to treat this more as like a constant, there's another method called list_of, and it does the same. It's basically the same thing, except the interface that it returns is a list. So that way, unless you do some weird typecasting stuff, it's guaranteed to not be mutable. So down here, if you try to say my list, there's no add method. So there's a lot more stuff with variables. So okay, one more thing. When we look at this, let's look at the decompiled Kotlin into Java. So this gets represented as just a field, but the way it's actually kind of represented in Java isn't always super important, because this is represented as a field, but something you can do in Kotlin that is kind of an anti-pattern in Java is this. So in Java, if you say like, it's kind of hard to switch back between Kotlin and Java constantly. Let's see. So you can do something like this, and but this is usually frowned upon because that means someone else's code can come along and so if you imagine foo is in a different class, then you can say, if you have an instance of properties, then you can change my name to whatever. That's fine. I mean, obviously it wouldn't be a public string if you didn't want people to do that. But if you ever want to change the implementation for my name, if you want to have it be like a generated property, so like if now you have like a first name and a last name, and you want my name to be generated from those two things, it's like first name and you wanted this to be, if you add these later and you wanted my name to always consist of those other things joined together, you'd be kind of stuck because now you have code that's calling you that is assuming that this is a public field, and you can't even if they're setting it, you've lost that control. You can't do any sort of method interception easily. So, okay, if we take the same situation in Kotlin, and we start out with a var my name is a string, and it's equal to foo. It's not a very good name, but I'm just not being very original right now. And if you look at the generated code from this, the difference is that this looks like a field, but actually it's actually a property. And this is just kind of a fancy field. So this part is a field, but there's now a getter and a setter. And also you can't set it to null because null checks. So now if you have another class that comes along and it constructs the types and it changes the my name, that still works. But now if later on we want to say, okay, let's have a first name and last name, and we want to change this. Okay, here's where it gets interesting. We want to change this so that it's always first name plus last name. So if you, well, okay, this is actually optional, but if you I prefer to leave the type on here. You can say get parentheses equals last name. So this also showcases another feature, which is templating, template strings. They're exactly this. You can say dollar first name. You can say dollar variable, and it will automatically interpolate it for you. You can also use something like this. If you want to have expressions, you can put it inside of a string like this using the curly brackets. So it's complaining right now because probably because this is a var. Oh, okay. So it wants to have an initial value, apparently. That might be because these things are defined after. No? Okay. Whatever. So now, anytime you get the value, okay, let's make this runnable. So another shortcut you can do in IntelliJ is if you type main, it'll suggest that for you. And then if we run it, it should print out m space a. Ta-da! Okay. So this wasn't exactly what we were doing before. Previously we were saying, okay, let's create a types object. Okay. And so now if we print this out, oh, right. Oh, right. Okay. So, interestingly, I'm not sure why it really lets you do this, but okay, whatever. So the get value here is always going to be whatever this method is. By the way, this is the expression syntax. Anywhere you're defining a function, you can use, if it's a one-liner, you can use a equal sign instead. This is equivalent, curly braces, and then you just say return. But sorry, not like a one-liner, but this whole value here is a single expression, which it's a value that you could assign into a variable. And if you want to convert this to an expression body, it's usually more clear. One of the things we wanted to do is to have this actually work, and of course, so what you can also do is do a custom setter. So usually you say value, and value here doesn't need a type because it has to be a string. So what we want to do is split value on the space and assign those to the first name and last name fields. So we can just say value.split, and this form is, there's some optional arguments that we don't care about, but accepts one or more character delimiters. So if we just split on space, then we set first name equal to part 0, last name equal to parts 1. We're not going to do any bounds checking because this is just an example. And then now if you run it, because we're actually setting first name and last name, we get the value we expect. So there's a few other things that the documentation will point out that I recommend checking out. Is you can, oh, okay, sorry, is you can say like private set, and then you can just be like, you can set this variable, but only if you're, okay, whatever. You can set this variable, but only if you're inside this types object. So if you say something like this, then here you can say my name equals whatever. But if you're outside of the types object, you can't reassign it because the setter is private. And in fact, if you look at the decompiled code again, When you scroll down, you can see the first name, last name are all public here, but the set my name is in fact actually private, and the getter is actually public. And also, you can see it's actually doing this is the template string. It's like, this is really just syntactic sugar for I'm gonna add, first name plus space plus last name, and this is how you would write it out in Java, but it's more concise because Kotlin. The last thing I wanted to share here is sometimes if you're not, like, my name is now currently not backed by any other field, really. It's fully derived from first name and last name. If you do actually want to have something that is backed by itself, maybe we don't need that. But if you want to have a set value here, then there's a special, I don't know, whatever it's called, pseudo variable called field. Okay, I guess I have to initialize it. And now, what this does is, if you like over here, you can say something perfectly natural, like confusing counter equals 10, and it will intercept that call and set the field to 11. So then if you println confusing counter, then you'll get back 11. And if we look at this generic code here, here we have get counter here is returning a field. The setter is doing what you expect it to do. It sets the counter to value plus 1, which is exactly what we said. Notice that in the update method here, even though it looks like we're setting a field, Kotlin will actually translate that into a setter. And so that was one of the questions I've always had in Java, is if you're mutating a field internally, do you use the setter or do you just access the field directly? Now you don't have to choose. You do whatever's natural, and Kotlin will translate it for you, which is essentially it always uses the setter. But when the JVM runs, it'll probably inline this so that it's actually not doing a method call. It'll probably just inline this into this method. Yeah, that's everything I wanted to cover. So next time we can talk a bit more about functions. And so we've been using functions, but I want to talk a bit more about how those work.